Hello class, in this video I'm going to be showing you how to solve an application problem that involves maximizing a quantity. Well, let's begin. Okay, so go ahead and pause the video and read the word problem. Welcome back. So the first thing I'm going to want to do is define the variables. So I'm going to look at the last sentence, and it states how many of each type of advertising ad should be used. So I believe there are 3 types of advertising ads. So I'm going to let x1 equal the number of newspaper ads. Next, I'm going to let x sub 2 equal the number of internet banners. And then I'm going to let x sub 3 equal the number of TV ads. Okay, now on to the objective function. All right, so I'm going to read the last part of the last sentence, and it looks like the store wants to maximize its ad exposure. So I'm going to go ahead and find the sentence that describes the ad exposure. And it looks like approximately 4,000 people will see each newspaper ad, 3,000 will see each internet banner, and 10,000 will see each TV ad. So here is the objective function. And this is where Z is the total ad exposure. And since we're going to use the objective function in a simplex tableau matrix, I'm going to go ahead and rewrite the objective function now. Okay. Next, we have the constraints. Okay, so going to the top of the word problem, it looks like the fancy fashion boutique has $8,000 available each month for advertising. So it looks like each newspaper ad costs $400 each. Each internet banner costs $20 each. And each TV ad costs $2,000. So here is the first constraint. That's going to be less than or equal to 8,000. Okay, now for the second constraint. It says that there'll be no more than 30 newspaper ads run per month. So that's going to be x1 is less than or equal to 30. Next, there'll be no more than 60 internet banners per month. And for the fourth and final constraint, there'll be a maximum of a maximum of 10 TV ads each month. And so now we're going to write each one of these constraints as an equality by inserting slack variables. And since there are 4 constraints, there will be 4 slack variables. Okay, so now we are ready to enter the constraints and the objective function into a tableau matrix. And it looks like we're going to need some more space here. Move that down a bit. Okay, and finally, we're going to enter the objective function. Okay, now that we have the simplex tableau matrix, let's go ahead and find the pivot. And it looks like the most negative indicator is the negative 10,000. So negative 10,000 is the most negative indicator. So what I'm going to do is I'm going to highlight the third column because our pivot is going to be in column 3. Okay, next we're going to take all of the numbers in the far right column and divide them by their corresponding entries in the second column. So x3 is equal to 8,000 divided by 2,000, which is 4. We cannot take 30 and divide it by 0. We also can't take 60 and divide it by 0, but we can take 10 and divide it by 1. So I realize that color is probably going to be a little light. So let's take a different color here. Let's go with orange. Okay, so now we notice that 4 is less than 10, so the pivot will be in row 1, column 3. So row 1, column 3. It looks like the pivot is 2,000. Okay, so now that we have the pivot, we are finally ready to answer the problem. And we're going to use PHP simplex to solve it. So let's go ahead and I'm going to hit the start key again. Okay, so how many decision variables are in this problem? And in this case, there are 3, because we defined 3 variables. there are 4 constraints. And again, make sure that we are on maximize. So now I'm going to enter the objective function. And now I'm going to enter the constraints. Oops. Well, that's going to be less than or equal to 8,000. Then we have 1, and make sure you enter the zeros for the coefficients of the variables that do not appear in the constraint. Okay, so let's just make sure we entered everything correctly, and it appears that we have. So I'm going to hit continue, and then I'm going to hit direct solution. And it seems like the optimal solution is 248,000 people that were exposed to the ads. If there are 17 newspaper ads, 60 internet banners, and no TV ads. So we're going to write that down now. So the maximum ad exposure of 248,000 people will be obtained by using 17 newspaper ads, 60 internet banners, and 0 TV ads. That still doesn't look like it's a 7, does it? There we go. And we are done.